In the Northeast, 30 to 40 inches of snow in less than 24 hours is rare. And when it happens, it's almost always lake effect. But last week's storm produced that much snow in a narrow swath about 300 miles long from northern Pennsylvania to New Hampshire. This zone got in a band of very heavy snow that shows up as yellow and bright green in these radar animations. First a wide view of the Northeast, and then a close-up centered on the Binghamton, New York radar. The band moved slowly last Wednesday night, snow accumulating at the rate of 4 to 6 inches per hour at times beneath it. The National Weather Service in Binghamton got about 15 inches in one 3-hour stretch and finished with 40 inches. So what was the recipe for this unusual event? Well, first you need the cold air. Here's surface temperatures at 7 p.m. last Wednesday, most of the state in the upper teens to mid-20s. But sometimes in these storms, warm air sneaks in aloft and changes the snow to sleet or freezing rain. Not this time. Here's a plot of temperature in red and dew point in green as a function of height. This is labeled in thousands of feet. This is last Wednesday evening in northern Pennsylvania. The horizontal axis is temperature in Fahrenheit. The temperature lines are slanted. That's why this is called a skew T diagram, T for temperature. And the only temperature that matters here is freezing, 32, which I've highlighted in black. Two key points here. Notice that from the surface up to around 25,000 feet, the temperature and dew point are pretty much the same. That means a relative humidity of 100% over a thick layer. This atmosphere is primed for precipitation. As for what type, notice that the red line always stays to the left or cold side of the freezing line. That pretty much guaranteed all snow. But why so much? Well, you see those purplish bars on the left-hand side of this diagram? The longer they are, the faster the air is rising, making taller clouds. Now, the fluffiest snowflakes grow most efficiently at heights where the temperature is between about 0 and 10. In this case, that layer was between these blue lines, which just happens to coincide with where the air was rising quickly and the relative humidity was 100%. So all the boxes were checked to efficiently make fluffy snowflakes that quickly accumulated on the ground. Finally, what made the air rise so quickly? Well, first, here's winds up around 5,000 feet last Wednesday evening. The colors indicate speed. Now you see this corridor of purple and red coming off the Atlantic. This is a pipeline of relatively light and juicy air that ran up and over the low-level cold air that was already in place. And if we go a little higher to 10,000 feet, this chart shows where fronts were intensifying in the mid-levels of the atmosphere. This is so-called frontogenesis. It's important because fronts help to lift air. And this arc of purple from Pennsylvania into New York State marks such a region, and its northern edge coincided pretty well with where the heavy snow band ended up. In the end, the storm itself never got that strong pressure-wise. It was a rather run-of-the-mill nor'easter, but it did develop an eye-like feature on satellite imagery, a characteristic usually reserved for storms that mean business. Stay tuned. Our extended forecast is next.